All right, hello again, everybody. It's your friendly computer science professor here. This is the sort of second of our review videos here at the beginning. This one we're going to go over the string and vector classes just from the sort of standard library. This one will be pretty short. We're not sort of doing anything really in detail. We're just gonna write some basic functions and loops and stuff here. So what are we trying to do here? We're trying to write a function called split. So split takes a string. The sort of parameter to it is going to be like a string, right? String, and then it's going to take that string and split it up wherever there are spaces. So like there's a space there, there's a couple of spaces there, there's three spaces there, one there, like that, right? Wherever there's spaces, we're going to split it into separate words. So what comes out the other side is going to be a vector of strings. String goes in, vector of strings containing the words, right, is what comes out. So each word of the input here, let me highlight those, right, becomes a value in the vector. So the becomes a separate value there like that. At becomes a separate value there like that. So forth. I won't do all of them, obviously, like that. That'd be boring. There's no spaces anywhere in any of the elements of the vector, right? Like none of these things in here have any spaces in them here. So the spaces are used to sort of determine where one word ends and the next word begins, but then they are sort of stripped out so that we're left with just the pure words there. And of course, like multiple spaces count the same as one space. So when I have like, two spaces here, or three spaces there, that counts the same as just having sort of one space in there. We want to write this function split that takes a string and splits it up into individual words there like that. In a lot of programming languages, this is like a built-in thing. This is what like cin does, right? If you just do a normal cin and you're typing stuff in, spaces and new lines and other forms of white space are used to sort of split up all the stuff that you're typed in there like that. So you can there's a built-in way to do this in C++. It's just like not like a simple function call. You have to like set some stuff up to make it happen there. But we're going to do it ourselves here. Okay, so the basic place we're going to start with, right, is we're going to do a ranged for loop over the characters in our string here. So our function is going to take in our string as its parameter, like that, right? And it's going to return a vector of strings there. We're taking our string as a const string reference rather than just like, string s. We're taking it as this sort of const reference, right? So what's the difference between saying that versus saying what we actually say of const string reference s there like that? If you do just a straight string s, right, what you get is a copy of the string there, which is normally fine, right? But it takes some time to make a copy. Like we saw the sort of copy constructor work in when we did the sort of bag based on a dynamically allocated array. So the copy constructor for string, just like there, has to loop over all the characters in the string and copy them into the new string there. That also means we're using like, extra memory because we're storing both the original string and the copy that we're sort of making of it here. Down here, if we do a const string reference, because it's a reference, it's not a copy. It's just a link back to the original string there. So we're not using like extra memory. We're not spending time like copying all the characters individually. And then the const here is because this function, like the copy constructor, like the copy assignment operator, we're not modifying the original string. Like we're not touching the original string. We're just taking it apart and sort of like pulling information out of it, but we're not going to modify it. So const is a promise that we're not going to change the original there like that. So that's just like why the parameter looks like that. And then the heart of our function is going to be some kind of ranged for loop like this, right? Just over the characters of our string. So this is just going to loop over the characters of our string from beginning to end here. If you haven't seen the ranged for loop before, or you're not like super familiar with it, it's pretty easy. It basically gives you what you want a lot of the time. So if you write this, right, if you write a ranged for loop there, that's exactly the same as if you just looped over the characters in your string from beginning to end, one at a time. So like, you've probably written like this style of loop here, whereas, I equals 0, I is less than size or length or whatever, plus plus I. You've probably written that a million times. Like that's how we sort of normally want to like access things in a vector or things in a string or whatever they're like that. So the ranged for loop is just a kind of a shortcut for that sort of thing here. The ranged for loop won't automatically work for like data structures that we create. So like if you tried to do a ranged for loop on, for example, the bag class, it won't work. You'll get a compile error because you do have to add some functionality to your class to kind of enable it. But it will work for all the sort of like built-in standard library data structures. So like it works on vectors, it works on strings, it works on arrays and so forth there. One other thing to sort of notice is like in this loop here, right? The character C, the sort of loop variable there, that is a copy of the characters from the string, which only makes a difference if you tried to like modify the characters. So like if in here I tried to do something like, oh, C equals, make a different character in there like that, right? That's not going to affect the characters in the original string here because C is a copy of the characters in the original string. The same thing is true over here. If I do something over here where I'm like, oh, I'm going to rewrite all the characters in the string with, exclamation marks or something like that, that doesn't actually change any of the characters in the string S there. So we can't just modify C and have it modify the characters in the original string there. There is a way to do a ranged for loop that makes that happen, where changing C does change the characters in the original string here. But again, like we sort of like made that const promise that we're not going to change the characters in the original string here. So if we tried to do it here, it just like, it wouldn't compile because we already promised that we weren't going to do that there. So this is just the sort of basic outline of like, we're just going to loop over the characters in our string one by one from beginning to end, and then, look at them with some kind of if-else sort of thing and use that to figure out like where are the words and where are the spaces here. Now, if you think about it, like, for a little bit, you sort of realize that like just looking at each character one at a time doesn't really give you enough information to know like how to split things up into words there, right? So the sort of example we gave was the string looks like the cat in the hat. And so the face, cat, face, in, face, the face. I'm not doing like the multiple spaces here. I'm just sort of doing a simple thing here like that, right? So imagine we see like in our loop, we see the letter T, right? We don't know, is that like this T right there at the beginning of the word the, in which case we should we need to start a word, right? We're sort of, that's the beginning of a word there like that, right? Or it might be like a T like the T in cat, right? It might be the end of a word, and whatever we need to do to sort of like, okay, this is the end of this word, record this word in a vector or whatever, like we need to do something different in that situation there. Or this string doesn't have it, but it could just be a T in the middle of a word. Like, you could have the word potato in your string somewhere, right? When you see the T in there, like it's just one more letter that gets added to that word there like that. So just seeing like one character at a time doesn't really give me enough information to sort of know what to do. I don't know like, hey, I need to start a new word, or I'm at the end of a word, I need to finish it up, or I'm just in the middle of a word. So what we need is some additional like context or some state about like, okay, this is the character I'm looking at, but like, where is it? Like, is it at the end of a word? Is it the beginning of a word? Like, what was I doing before I got to this character there? So I have not just my character, but this other sort of thing that I'm tracking here. There's only really two sort of like states that we need to worry about here. Like, we don't need to sort of like consider like, oh, the previous character was a Q or something like that. All we really care about are, were we previously working on building up a word? In which case, if we see like a T, it's just another letter that goes in the word. Or were we previously scanning over some spaces? If we were scanning over some spaces and we see a T, like that means something has happened. That means we're seeing the T that is the beginning of a word and we need to do something different there. So we're going to have sort of two possible like states that we need to worry about. We're building a word or we're scanning over spaces. And then in terms of characters, like there's not really a difference between the letter T and the letter Q or like a number or whatever they're like that. We only really care about, is it a space or is it something else? Like every other character that is not a space counts as like a word character there. So those are the sort of two interesting like sort of classes of characters. We have two possible states and we have two possible like types of characters. We have two states, right? And we have two kinds of characters. That means we have a total of four sort of things that we need to look at. Four sort of like scenarios that we're sort of interested in here. So we can make like a little table here that sort of shows each of those four situations and think about what do we need to do in each one of those situations. So this is that table here. Across the top right, we have our characters, or like sort of kinds of characters. So we have spaces and we have everything else. And then over here on this side, we have our states, right? Like we're either looking at a space or we're building up a word there like that. And then we're just going to fill in this table from sort of like, top left to bottom right there. So this top right box up here, this is the current character. So my current character, like what I'm looking at right now, is a space. And then my context, my state over here, what was I doing previously, is I was previously scanning spaces. So in terms of like the string, you can think of it as like, okay, I have some spaces and then I see another one. So this is where I'm at right now. I don't look into the future, right? I'm just looking at what is the current character right now. It's a space after having seen some other spaces there like that. So in this case, like this space doesn't give me any new information. I don't know what's coming next. So all I know is like, hey, I previously had some spaces and this is yet another one. So all we're going to do in this situation is we're going to throw that space away. We're just going to ignore it. We don't care about spaces, right? They don't show up in the output. And then we're going to stay in the space context. Like this doesn't give me any new information. So all I'm going to do is like, I'm still doing the same thing that I was doing before. I'm still scanning over spaces there like that. So that's the upper left sort of quadrant corresponds to that. Now the upper right one over here, right? I'm in the space state. So that means like previously, what did I see? I saw some spaces. But then my next character is a non-space character. So maybe it's like the T or something like that. Right? So this is where I'm at right now. I'm looking at that. So if previously I saw some spaces and then now I see this, that means this is the beginning of a word, right? Like I was sort of like skipping over the spaces that I don't care about, but now I see an actual letter or something here. So what we're going to do in this situation is we're going to start a new word, whatever that means. Like we'll figure out the code for it later, right? But like this is the beginning of a word. We're going to start a new word. And then going forward, we're now building up a word. So we're going to switch to the word state. So we're going to sort of like move from here down to here, and then we'll be looking at stuff in the bottom row there like that. All right, then starting on the bottom row. Okay. This one here, this state, this sort of like scenario is the opposite of the one before. So again, now we're looking at something like this. So we've got, let's say T, H, E, and then a space. And again, we don't know what's coming up in the future there like that. So now we were scanning over word characters, but we're looking at a space. So our previous sort of context was word, but the current character is a space there. So this is the opposite of the one we just looked at. In this case, we're at the end of a word, right? We just finished building up the word, in this case, the or whatever there. So whatever we have to do to like finish up a word, again, we'll figure out the code later on in a second here. That's what we're going to do here. And now we're no longer building a word, so we're going to switch back to the space context, back to the space state there like that. And again, we'll be back in the sort of top row there. And then the final quadrant in the bottom right. So this is, I'm in the word state, so that means I was like looking at a word. That. And my character is not a space character. So like I'm looking at, say, the T here in potato. I don't know that there's an O coming up, right? I don't look into the future. All I know is that I have one more word-like character after having previously seen some word-like characters. So this is just another letter in the word that I'm building up. So I am going to just add that character to the word. And again, like nothing has sort of changed. I'm still building a word, so I'm just going to stay in the word state there like that. And like I'm just adding more stuff onto this word that I'm sort of building here. We can also sort of like draw this whole setup here as a deterministic finite automata, if you like sort of like big words there. If you don't like big words, you can just call it a finite state machine. So this diagram here has all the information that the sort of previous table has here. If we are in the space state, right, if we were sort of previously scanning through spaces, then the two arrows that come out of the space state, like this one here, right, and this one down here, like that, tell us what do we do when we see a space character? Excuse me. And what do we do if, what do we do if we see a non-space character? And what do we do if we see a space character? And then the sort of actions that we take are written in blue underneath here. So if I am in space and I see a non-space character, then I'm going to start a word, and then I'm going to switch. I'm going to move over here into the word state on the sort of right-hand side there. If I'm in the space state, and I see a space character, I'm going to take this sort of like little loop down here, which means I stay in space, but I'm going to discard the space character. Once I'm over here in the word state, if I see a non-space character, I just sort of collect it up and add it to my word. But if I see a space character, I'm going to take this loop here and move back into the space state, while doing whatever is necessary to sort of finish up the word that I'm looking at like that. So this little sort of like diagram here has all the information that the table sort of previously has, but in like a sort of nice graphical format there like that. This also shows what the table doesn't show, which is what state do we start in at the beginning of the string here. So here we're saying we're going to start in the space state. So at the very beginning of the string, before we look at any characters, our sort of default state is going to be the space state there. Okay. So inside of our split function, we're going to need variables other than like, the C variable that is for the sort of character, the S variable that is for string. We're going to need to add a variable for the vector that we're going to return. Like if we're going to return a vector, it makes sense that we would have a variable that is that vector there like that. But then in addition to that, I need a vector for the word that I'm building up. Like I can't, add characters onto a word, build it up character by character without having a string representing that. And then finally, I need a variable that is telling me like what state I'm in, right? My state can change as I sort of scan through the string. So I need a variable to keep track of what is the sort of current state here like that. Now, you could do the state as something like this. You could just be like, okay, int state. And then you could just sort of like, remember on your own, give yourself a little comment that like, okay, 0 means space, right? And 1 means word, like that. And so then you would just be like, okay, if state equals 0, if state equals 1, like that would work just fine. You could also, you know, do something like with a bool, right? Because we only have 2 possible states, and a bool has only 2 possible values. But again, you'd have to kind of like mentally remember that, okay, let's say false means space, etc., right? True means word there, like that. And that's a little bit like annoying. So it turns out that like C++ has a built-in thing that will let us sort of give nice names to our states. So we're going to define our vector of words is just a vector of words. Our string for the current is just a string. But my state is going to be represented as this enumeration variable here. So what this is sort of like a shortcut for is, imagine defining 2 constants. So we have a const int space whose value is 0. And then we have another const int word whose value is 1. So those come from just in here. Space is 0, word is 1. But I don't really care about the values. I don't care about those numbers here. I'm just going to use the names. I'm just going to use space and word here. So like right here, right over here, I can just say state equals space. I don't have to worry about like, is a space a 0 or a 1 or whatever they're like that. So whenever I have like a thing whose value can be like, you know, 1 of 2 things, or 1 of 5 things, or 1 of 10 things, or whatever, and the 10 things all have sort of like names assigned to them, we can use this enumeration sort of thing here to let us like just use the names and not have to mentally remember, okay, 0 means this, and 1 means this, and 2 means this. So that's just sort of all that is doing in here. And then the body of our ranged for loop, right, is just going to be this sort of 4-way if-else kind of thing, checking for each of the 4 cases in the table that we built up previously. So we'll just go over them like one by one here. So the first thing in my if is we're going to say if the state is space, and if my character is a space. So that corresponds to that upper left quadrant. So in the upper left quadrant, we're going to throw the space away. We don't care about it. So to throw it away, we just don't do anything with it. Like, we're not literally like removing it from the string or anything. We're just saying we're not going to like, you know, do anything with it. So I just don't do anything with it. And then we want to stay in the space state here. Now, of course, I could leave this, like, I don't have to say state equals space. If state is already space and I just don't change it, then we will stay in space. But just for consistency, I'm going to put at the end of each one of these what the state will be sort of going forward here. So this like last line here, this line is you know, optional if you wanted to like sort of remove it. But I'm going to end all of these with like a state equals something, just so that they're all sort of consistent with each other there. The next one here, right, we're still saying that we were previously scanning spaces, but now the character that we're looking at is not a space. It's a non-space character. So this corresponds to that like upper right quadrant. So if I was previously scanning through some spaces, I saw some spaces like that, right? And then I see a non-space character. That means we are starting a new word. This is the first character of a word here, so we're going to need to start a new word here like that. So current, remember, is a string. It represents the word that I'm building up. So I'm going to take the character and add it to that string here like that. So that string starts out as empty, so this is literally just saying that C is going to be the first character of the sort of word that we're building up. So C is going to be the first character of the string current. This next one down here, this corresponds to, okay, I was scanning a word, but now I see a space. So this is the scenario where we were seeing something like Cato space, right? We're looking at that space right there. What does that mean? That means that we are done with a word there like that. So we're going to finish the sort of word that we're looking at here and then switch back to space. So to finish my word, I'm going to take the current word and then add it on to the end of the words vector. So pushback for both strings and characters adds something onto the end of whatever you already have before there like that. Up here, when we use pushback, we're adding a character onto the end of a string. Down here, when we use pushback, we're adding a string onto the end of a vector of strings here. Now, I just actually noticed there is a small bug in this code here. So if you try this out, you will definitely notice it here, but you might want to take a look at it and just sort of see if you can sort of figure out how this will go wrong. But I'm going to sort of move forward and then I'll kind of like explain like how this is sort of broken in a second here like that. And then the last combination, this is like the lower right quadrant, right? So we're scanning a word like that right there. And our current character is not a space. So that means we're in the lower right quadrant. We just discovered one more character in the middle of a word here like this, right? So if I'm looking at the second T in potato, right? I don't know that there's an O coming up, but this is just like one more word character in the middle of a word here like that. So what do I need to do here? I just need to add it on to the end of the current word that I'm building, and we stay in the word state there like that. You could kind of simplify this down here because some of the cases are sort of like shared in common, right? So if we sort of notice that like to stay in space, we don't need to actually like, do that. We could just sort of like leave that one out. Like, so the whole first if could just be blank like that. And then like the other ones, some of the cases can be sort of combined because they basically do the same thing there like that. So you could sort of condense it down, but I'm going to leave it as like, a four-way if else, just so that like it sort of matches the table that we built up earlier there. Like that. So if you try this version on some strings here, in fact, from the mistake that I noticed earlier, it won't even look like this. Like even this one won't look like that right there, and this one won't look like that right there. But also, you'll also sort of discover that these ones over here kind of like fail in an interesting way here. So actually, let me do this. Let me go and give myself here a new page. New page here. There. Copy that, right? So this one here, if you feed it this string, what you will get out is not this here. What you will get out is the first word comes out okay. Comes out as that, right? But the second word will come out as the cat. And then the third word will come out as the cat in. And so forth, like that. Likewise, like down here, you won't get this out. What you will get out of the whole thing is you will get out, again, the first word comes out okay, but then the second word includes the first word. And then the third word includes the first two words like that. So the problem with this, let me go back to the sort of code that we looked at, right, from up here, is in, let's see, this one right here. So let me clean this up a little bit. We can see where the problem is. So the problem is when we sort of start out, right, the value of current, when the function begins, the value of current is the empty string. So when we start a new word and we add a character onto current, we are adding the first character of that sort of word there like that. But that's only true at the very beginning, right? After we finish scanning the sort of first word and we start on the second word, current still contains the first word in it there. So as part of finishing a word, I need to delete everything out of current. So I need to insert something in here where we basically do current dot clear. to clear the contents of current there like that. Another way you could write that would just be to say current equals the empty string. And I don't have to do that there. You could also do that as part of like starting a new word. So before you start a new word, before you add that first character, you could clear it there. But we have to do it somewhere. Somewhere we need to sort of clear everything out of the current word, or otherwise, as we sort of build up later words, they're just going to add on to the words that sort of came before there like that. So sorry about that like sort of bug in this code here. I think I might have actually intended it in some way or something like that, but that's a fix you would have to sort of make here like that. When I upload the code into Canvas, I'll incorporate that fix into it there so you don't have to like manually edit yourself. Anyway, where were we? We're down here, right? So if you make that sort of fix here like that, you'll discover that there's another bug in this, which is that it forgets the last word sometimes. So if your string ends with a space, everything is fine. But if your string doesn't end with a space, then it will miss the last word in it there like that. So the reason for that is, again, sort of if we go back to the code up here like that, right? We only add a word to the vector if we see a space, right? Seeing a space sort of triggers the finish word action that sort of makes words get added to the vector. So if the string ends with a space, we will take the last word that was sort of still being built up and add it to the vector. But if the string doesn't end with a space, there's nothing to sort of trigger that sort of finish word action, and that last word is just thrown away. So the trick for that is just after the loop ends, we're going to add a little bit of code to just basically say, are we still building up a word? If so, add it on to the end of the vector there. So to do that, we can just check the state at the end. So this is after the loop, right? We have our for loop, blah, 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 blah. Curly brace ends the for loop here. Right before we return the sort of vector, we say, wait a minute, were we still building up a word when the loop ended? If so, then we're going to finish the word here. So that's what this is doing. This is doing the finish word action, if necessary, when the sort of loop ends there like that. So the final code for this, not including the sort of fix, which I'll add here. So the fix we had to add was when we finish a word, we also are going to clear the current word. So current dot clear. We have to add that as part of that sort of there. Obviously, you want to do that after you add the current word to the vector. You don't want to add like an empty word onto the vector there like that. This is sort of like the sort of final state of our function there like that. We'll come back to this. We'll use it in a few other places where we need to do like, you know, nice input. We want to sort of like accept input as like sort of space separated words for various things there like that. But hopefully that was a sort of useful review over some sort of elements of strings and vectors, right? So for strings, we can do pushbacks, add new characters onto the end. We can do the same thing for vectors, same operation there like that. We can do the ranged for loop over both strings, and if you wanted to, over vectors. And then we won't really use it much later on, but we have this enumeration variable here that can be convenient if we have a value that can be one of a few different sort of things there like that. So that's the code for our sort of split function here. Now, leading into what we're going to talk about in the sort of beginning of the next module, module 2, a question that you might want to sort of ask yourself is, oops, do that right. As you increase the length of the string, how will the runtime of this function change? Like if I have a string that, takes, a string that is like, let's say 10,000 characters long, right? And I run the function and it takes, 15 milliseconds to run or something like that, right? So I 10,000 character string, 15 millisecond runtime. Let's say I double the length of that string from 10 to 20,000 characters. How would you expect the runtime of the function to change? Like as I increase the length of the string, does the runtime of the function stay the same? Does it get bigger? Does it, maybe get smaller, something like that? That's going to be a major theme of our sort of next section, is basically like, how do we sort of like describe that relationship between the size of something and its effect on the runtime of functions that sort of use it there. But that's it for this one here. So hopefully that was sort of helpful and useful. So I will see you, proverbially speaking, next time.